This video is going to run through several different types of unit conversions. Let's start by considering units in the American system of measurement. I have listed on the screen lots of different conversion factors. For example, when we're talking about length, 1 foot is 12 inches, a yard is 3 feet, and a mile is 5280 feet. When we measure volume or capacity, a cup is 8 ounces, a pint is 2 cups, a quart is 2 pints, a gallon is 4 quarts. Weight, 1 pound is 16 ounces, and a ton is 2,000 pounds. We can use all of these different conversion factors to solve problems like the one I have listed on the screen. Convert the following. 1 inch equals blank feet. So we need to convert inches into feet. I'm going to show you a technique that's often referred to as dimensional analysis. This technique is frequently used in science classes, such as chemistry classes. So I'm going to start by writing down the number that was given to me as a fraction over 1. So 100 inches over 1. And I'm going to include the units. I'm going to include that inches when I write down that number. Then I'm going to multiply by a conversion factor, and I'm going to keep track of the units to help me figure out exactly how to write down my conversion factor. In this case, I am trying to convert inches into feet. My conversion factor is 12 inches equals 1 foot. I can write that as a rate. To figure out how to write that, I'm going to look at 100 inches over 1, and I'm going to write that conversion factor so that the inches are on the bottom and the feet are on the top. And the reason I'm doing this is when we do math with units, the math has to also work with the units. I want the inches to be on the bottom because then I have inches on the top and the bottom. And just like I would cancel out a common factor, I can cancel the inches out and I'm left with feet. And feet is the unit we want. So my conversion factor was 12 inches equals 1 foot. So I put the 12 inches on the bottom and the 1 foot on the top. That means I can multiply the number given to me, 100 inches, times 1 foot over 12 inches. Again, this allows me to cancel the inches out, and then I just multiply straight across. 100 times 1 is 100. 1 times 12 is 12. So my answer is whatever 100 divided by 12 is. I'm going to reduce before I do that division. Both of these numbers are divisible by 4. 100 divided by 4 is 25. 12 divided by 4 is 3. So now I've got 25 divided by 3, and 3 goes into 25 8 times with 1 left over. So I can write this as 8 1/3 feet. So 100 inches is 8 1/3 feet. Here's another problem. 0.25 miles equals blank feet. So I'm going to write down the number that's given to me as a fraction over 1. 0.25 miles over 1. I'm going to multiply by a conversion factor, and I want to make sure I put miles on the bottom so that the miles cancel out, and I'd like feet to be on the top because that's the unit I want to have left. So I want to multiply by a conversion factor that's feet over miles. If I go back and I look at my list of conversion factors, I know that 5280 feet equals 1 mile. Again, that mile goes on the bottom because then the miles cancel out and we're just left with feet. We're going to have to multiply straight across, so we're going to take 0.25 times 5280, and that's going to be over 1. So 0.25 times 5280. 5 times 0 is 0. 5 times 8 is 40, carry the 4. 5 times 2 is 10, plus 4 is 14, carry the 1. 5 times 5 is 25, plus 1 is 26. And then I just write down a 0. 2 times 0 is 0. 2 times 8 is 16, carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 5 is 10. Add 0, 0, 10, carry the 1. So that's 12, carry the 1, 3, and 1. The numbers I'm working with have 1, 2 places after the decimal. So my product, my answer must have 1, 2 places after the decimal. So this is 1320 feet, 1,320 feet. Here's another one. 3/4 of a gallon equals blank cups. So I'm going to write down my number, 3/4 of a gallon. And this time, because I have a fraction, I don't actually have to do the over 1. I can just write it as 3/4. That's my fraction. But I am going to put that gallons on the top, just to help me with my dimensional analysis. Now, so if you go back and you take a look at our list, there wasn't something that listed how many cups were in a gallon. Instead, I know that 1 gallon is 4 quarts. And so I'm going to write down that conversion factor, putting the gallons on the bottom. So gallons cancel out. And that's going to leave me with quarts. Then, if I take a look at my list, I know that 2 pints is 1 quart. So I'm going to write down a second conversion factor. And you can keep multiplying by conversion factors until you get the units you want. So 1 quart is 2 pints. The quart has to be on the bottom. Now the quarts have canceled out, and I'm left with pints. And then finally, 1 pint is 2 cups. Notice I put the 1 pint on the bottom, so the pints cancel out. And I am left with cups, and that's what I wanted. Again, you can always double check the math with the units, and that tells you whether or not you have the problem set up correctly. So we started with gallons. Gallons on top and bottom cancel. Quarts, top and bottom cancel. Pints, top and bottom cancel. All we're left with is cups, and that is the unit that we want. And so now we can actually just multiply straight across. I've got 3/4 times 4 over 1 times 2 over 1 times 2 over 1. Before I do some multiplying, I do notice there is a common factor of 4 on the top and the bottom, so I just might as well cancel those out. And then I'm left with 3 times 2 times 2. That's 12. So final answer is 12 cups. All right, here's one more. 4 square feet equals blank square inches. Same process. I have 4 square feet, and you can write out square feet like I did in black in words, square feet, or you can actually put a little 2, a little squared with the foot, and that means the same thing. So I've got 4 square feet over 1, and my conversion factor is I know 1 foot equals 12 inches. Now notice that 1 foot equals 12 inches. These are not square inches and square feet. These units are not the exact same. And so if you want to cancel out a square feet, you actually have to multiply by the conversion factor twice. So if I multiply by 12 inches over 1 foot twice, then what happens is on the bottom I have foot times foot, that's square feet, and those cancel with my square feet. And then I'm left with inches times inches, which is square inches. So basically, anytime you're working with an area unit like square feet and square inches, you have to multiply by that conversion factor twice. So now I'm left with 4 times 12 times 12, technically over 1. 12 times 12 is 144, and 4 times 144 should be 576, and that's my final answer, 576 square inches, or inches squared. Now, if we're working in the metric system uses common prefixes to describe units that are all related to each other by powers of 10. So that actually makes the conversion a tiny bit easier, because if our conversion factors are all powers of 10, it turns out our conversions involve simply moving the decimal, either multiplying or dividing by powers of 10. And so I have a table right here that summarizes our common metric prefixes: kilo, hecto, deca, deci, centi, and milli. And so how this table works is if you have a base unit, and so a base unit might be something like grams, if we're talking about the weight of something, meters for length, liters for capacity. You can have other units as well, but those are our most common base units. Then you can attach a prefix to that base unit. So for example, if we're working in grams, 1 kilogram, we abbreviate that as kg, so 1 kilogram. This table is telling us a kilogram is 1,000 grams. 1 decigram, which we abbreviate DG, is actually 0.1 grams. So that's how this basic table works. You can have milligrams, centigrams, etc., and the relationships are described in this table. So basically, if you want to do a conversion in the metric system, because we're always either multiplying or dividing by powers of 10, that arithmetic can be done by just moving the decimal. And so to do problems in the metric system, I actually just jot down our metric prefixes. And so I just wrote down below my table in red the abbreviation for each of my prefixes: K for kilo, H for hecto, DA is deca, and then I leave space for our base unit. The base unit means you could just have grams or liters without a prefix. And then D is deci, C is centi, M is milli. And if you write down your metric prefixes, all of them in this order, then we can do our conversion by simply counting how far is one prefix to the other, and that actually tells us how much to move the decimal. So for example, if I want to convert 45.7 centimeters into millimeters, one method we can use is we can jot down those metric prefixes in order: K, H, DA, base unit, D, C, M. In this problem, we want to move from C, centimeters, to M, millimeters. When I jot down my metric prefixes in order, I notice that to go from C to M, I have to move over to the right one place. So that means if I want to convert centimeters to millimeters, I can take my decimal and move it over to the right one place. And that's exactly what I'm going to do. So 45.7, I'm going to take that decimal, move it over one place to the right, and that gives me 457 millimeters. This works because each of these metric prefixes, when you move from one to the next, you go up by a factor of 10, which just moves that decimal. Let's do another example. Let's see if we can convert 125 grams into hectograms. So I jot down my metric prefixes, and in this case, we're starting with something that doesn't have a prefix. It's just a gram. There's no letter in front of it. So we're starting at our base unit, which I denote with that little slash. We want to move to the H, hectograms. So to get from my base unit to hectograms, I have to go 1, 2, over to the left. I have to move 2 places to the left, and that is exactly what I'm going to do with my decimal. The number we have is 125, so the decimal is technically at the end. I'm going to move 1, 2 places to the left, and that gives me 1.25 hectograms. This process will work for all of your metric unit conversions that use these prefixes. Now, sometimes we have to convert between the American system and the metric system. And so on the screen, I have a list of some common conversions. For example, 1 inch is 2.5 centimeters, 1 meter is 1.09 yards, 1 kilometer is 0.62 miles, 1 kilogram is 2.2 pounds, and 1 ounce is 28.35 grams. If we're converting between the American and the metric system, we will go back to that dimensional analysis, but sometimes we'll also have to move the decimal. And so let me run through a couple of examples to illustrate what I mean by that. Let's convert 45 inches into meters. So looking at the list of numbers I have something that will convert inches into centimeters. So I'm going to go ahead and do that conversion first. If 1 inch is 2.54 centimeters, I'm going to write down 45 inches over 1 times 2.54 centimeters over 1 inch. I know I have this written down correctly because the inches are going to cancel. We have inches on the top and the bottom, and we'll be left with centimeters. So I'm going to take 45 times 2.54, and I got 114.3 centimeters. So first thing to do is take your American measurement unit and convert it really to anything in the metric system. Now I'm going to move the decimal to get my centimeters into meters. So I jot down my metric prefixes in order. I'm starting at centimeters at C, and I want to get to just meters, the base unit. So I have to go 1, 2 places to the left. I'm going to do the same thing with the decimal. I'm going to take my decimal and move it 1, 2 places to the left, and that gives me 1.143 meters. Last type of conversion I'd like to show you is converting between different units of temperature. And we'll be talking about working with temperature measured in Fahrenheit as well as in Celsius. And so to do our conversions in temperature, we're actually going to be using formulas. In the formulas I have listed on the screen, the F stands for Fahrenheit and the C stands for Celsius. So if we want to find a temperature in Fahrenheit, we can use the top equation. F equals will give us a Fahrenheit. If we want to find a temperature in Celsius, we can use the bottom equation. Celsius equals. So let's do an example. Let's see if we can convert 22 degrees Fahrenheit into degrees Celsius. So I want to find degrees Celsius. I'm solving for C. So I'm going to use the second formula. I want to find Celsius. So there's my formula. C equals 5/9, parenthesis, F minus 32. To do this conversion, I'm going to take the 22 and just plug that in for F and then solve. So C equals 5/9, parenthesis, 22 minus 32. And now this is a PEMDAS problem. I work inside the parentheses first. 22 minus 32 is negative 10. And then I can multiply. 5/9 times, technically it's a negative 10/1. If I multiply straight across, that gives me negative 50 over 9. And then I'm going to write this as a mixed number. 9 goes into 50 5 times, right? 5 times 9 is 45. So remainder of 5. And so I'm going to, write this as negative 5 and 5/9 degrees Celsius. So somewhere between negative 5 and negative 6 degrees Celsius is my 22 degrees Fahrenheit. 15 degrees Celsius equals blank degrees Fahrenheit. So now I'm solving for degrees Fahrenheit, so I'm going to use the other formula. F equals 9/5 C plus 32. I'm going to take the 15 and plug that in for C. So now I've got F equals 9/5 times 15 plus 32. 9 over 5 times 15 over 1. We multiply before we add. I notice that the 5 and the 15 have a common factor of 5. 5 divided by 5 is 1. 15 divided by 5 is 3. And then I can just multiply straight across. 9 times 3 is 27. And then over 1. So 27 over 1 is 27. Plus 32, that is 59. So 15 degrees Celsius is the same as 59 degrees Fahrenheit. All right, that was my last example. I know there are a lot of different types of conversions in this video. If anything was unclear, please do reach out.